Hi, I am Priyanka. I am going to give seminar on SDN, that is Software Defined Networks. Today's agenda will be introduction of SDN, then we'll see traditional way of handling networking environment, then what was the need of SDN, how it works, example of SDN, and later we'll conclude it. SDN, basically it is operating system for network. SDN abstracts the networking hardware in an infrastructure and separates the so-called control plane from the data plane. Control plane is the part of networking that decides where the data must flow and at what priority or service level. Data plane does work of data forwarding instruction on a per packet basis. SDN is enabling organizations to accelerate application deployment and delivery, dynamically reducing IT costs through policy-enabled workflow automation. SDN technology enables cloud architecture by delivering automated on-demand application delivery and mobility at scale. SDN enhances the benefit of data center virtualization, increasing resource flexibility and utilization and reducing infrastructure cost and overhead. As you can see in the diagram, it's a huge network and it has a router, switches, many devices connected in a same network. It can be even more large or huge, it can grow. So how to validate responsiveness as demand varies according to the user need, and how to configure firewall and load balancer. Then how do we eliminate security problem and exposure between user and application. How to easily configure huge network. So these are the problems here. So for this we will have to go at each device and set the logic, which is not efficient and practical in today's dynamic growing environment. So here we'll see the limitations. Let's see some more problem in the current networking environment. As you can see in the diagram, we have some networks of router. Each router is having its own proprietary operating system, control logic in terms of app, and a specialized hardware for forwarding packets. This is a very closed environment. So changing anything on these nodes will be a tough and expensive operation. The limitation continues here, and you can see for operating system and feature we have to write millions of lines, and for hardware we should have billions of gig, and there are many complex functions baked into infrastructure like OSPF, BGP, multicast, etc. So no control plane abstraction for the whole network. It's like old time when we didn't have OS. Need for SDN. To solve a huge and complex network, we need SDN. We know the network is changing dynamically, so these devices should also do the same. And it should be easy to maintain and it should not be very costly. And as the change occurs, the speed should also improve. Now we will see the working of SDN. Let's make the router open. As you can see in the diagram, it is closed. So let's make the router open. By this I mean that we are removing some of the component from it. Basically we are separating control plane and the data plane. The key is to have a standardized control interface that speaks directly to the hardware. And a whole network is like a big machine. So here you can see the bigger picture of SDN. A remote controller has control of switches forwarding decision. Whatever I said in the previous slide is shown in this picture. The entire SDN idea is depicted in this picture. OpenFlow. OpenFlow is an implementation of SDN. It uses some of the aspect of SDN and basically it enables the in, uh, basically it makes the interface between switches and network OS, and it enables innovation in campus networks. Like ordinary, it has a data path, which is hardware, and a control path, which is a software. So what we do is we replace the control path with the control path and open flow. And here we have a controller, open flow controller, which talks to open flow. As you can see in the picture, there is a logo of open flow. It is a standard way to control flow table in commercial switches and router, and it just need to update firmware. Essential to implement of essential the implementation of SDN. Suppose you can see in the diagram. Suppose this is the user, and she wants to. She's having a great algorithm that she wants to put on each node. How she will do it? Well, she'll just forward it to controller, and then controller will broadcast to the all nodes in the network. So it is very easy compared to the traditional way. Conclusion. It is a system layered abstraction which is programmable, flexible, and extensible. OpenFlow, which is an implementation of SDN and which uses the aspect of SDN, it is interface between switches and the controller, and it enables SDN in it. Thank you.